Let's take a look at number 7. We got f of x is equal to 3 over x plus 3, and g of x is equal to 7 over x minus 7. And they want us to find f plus g. Well, to add these two together, we just add together the individual functions. So we got 3 over x plus 3 plus 7 over x minus 7. Now this is, let's go through these steps. Now again, this problem's a lot easier than the steps might indicate. So this is adding / subtracting rational expressions with different denominators. Okay, step 1. Factor all denominators. Step 2. Figure out the least common denominator, LCD, and rewrite each fraction with that new denominator. Step 3. Add or subtract the top parts, the numerators, and put into a single fraction. Now at this point, our denominators should already be factored. So I'm going to say factor the top and factor the bottom, but actually we shouldn't have to do the bottom. But just in case you actually multiplied it through by accident. And then 5, cancel if necessary. So let's go through these steps with this problem. Okay, first step, factor all your denominators. Well, x plus 3 and x minus 7 can't do anything with. Like I said, this is a pretty simple one. 2, figure out the least common denominator, rewrite each fraction of that new denominator. And how we do that is we go with each factor. I'll start with the first one, x plus 3. And I'm looking for the greatest number of x plus 3's in any single denominator. I got 1 here, I got none here. So again, we're looking for the greatest number of x plus 3's in a single denominator, which would be 1. Then I go to my next factor, the x minus 7, and I'm looking for the greatest number of x minus 7's in any single denominator. There's none here, there's 1 here. So the greatest number of x minus 7's in a single denominator is 1. So that's our LCD. Now what we do is we look at what the old denominator had, the x plus 3, which is still there. The new thing we put next to it was x minus 7. So we have to put it next to the top part. If we look at our second fraction, it had an x minus 7. The x minus 7 is still there. The new thing we put downstairs was the x plus 3. So we have to put the x plus 3 up here. Basic rule on that is wherever you multiply by the bottom, you have to multiply by the top. Well, 3 times x is 3x. 3 times negative 7 is negative 21 over our denominators. 7 times x is 7x. 7 times 3 gives us 21 over these. Step 3. Add or subtract the top parts and put into a single fraction. Well, this is a plus in between them, so we're going to have 3x minus 21 plus 7x plus 21 all over x plus 3, x minus 7. Now, no matter where you are in math, combine together like terms. 3x plus 7x is 10x. Negative 21 plus 21 drops away. Now, we don't have to do the last steps. Factor the top, factor the bottom. Well, the bottom's factored, but top I can't do anything with. I mean, I could rewrite it as 2 times 5 times x, but nothing will cancel with the bottom. So that's actually our answer. So let's see. 10x over x plus 3, x minus 7. X plus 3, x minus 7 looks like b. Now they also put the domain on there. They didn't specify that in the original instructions. But to find a domain, you set your denominator equal to 0. And this is already the factor and 0 on this side. So 0 factor property says we set each factor equal to 0. So I'll set x plus 3 equal to 0 and x minus 7 equals 0. And solve those. And we get negative 3 and we get positive 7. Now these are the values that if I put them up here, they'll give me a 0 in the denominator. 7 minus 7 is 0, and 0 times anything is 0. So these are the values we cannot have. So we put a slash through them like that. And that's what they're indicating there. X cannot equal to negative 3 and 7. So let's check our answer, 7b. And it checks. Not that I doubt my work, but sometimes I doubt my typing. So as I type these in, sometimes I mistype things. So that's what I'm checking.